Welcome to another Great Car Basic training session, and today we are going to be covering how to use the software to manage a timer to flash an LED, but this time we're going to be using a timer interrupt. We're going to be using Timer0 Overflow interrupt. There are other timers and other interrupts that you can use, but this is representative. Okay, so let's get cracking. We're doing session 14, and tomorrow we'll be covering sending serial data to the LCD. Now, I'll explain why we're doing that tomorrow. What I've got is a microcontroller. It's a 16F18313 and it's connected to a PIC-Kit2 programmer. It's a very small device with 8 legs, and with those 8 legs you can do quite a lot. Okay, so what we've got is this board. This board here is in, let me have a look at the lab camera. It looks like this. It represents it. Okay, so what we're going to be doing is flashing an LED, and that LED is going to be, we'll put in this one here. It's connected through a resistor down to the microcontroller. We will set up the timer inside of the heart of this 16F, and we will then add an interrupt to make that work. Now we have to do 4 things on the to set up the timer and clear a flag, and we did that in session 13. So let's get into what we're trying to show you here. Okay, now this is lovely block diagram showed in session 13 where we selected and set up a series of parameters along this sort of chain to raise an interrupt here. Well, I've redrawn it to make it a bit more meaningful. Okay. So why are we using timers? Timers can generate accurate delays. They can be measured. They can generate loops in your program. And with these new microcontrollers, the one we're looking at, we can relieve you having to do a lot of the calculations in your own program by using these pre-scalers and post-scalers. So in the older chips, you'd have to do a lot of that coding by hand. But we can do it in these pre-scaler and post-scalers and get some very large delays. So a timer is nothing simple. Is nothing simple and nothing hard. Sorry about these counters. They count up to a number, and when they get to 0, they raise an interrupt flag as per this diagram. And this diagram, we'll walk through this very quickly. So yesterday we had to select. We're going to select an oscillator. I'm going to select an oscillator. It's going to be an internal oscillator, not an external oscillator. Okay, and that generates a signal. This one I'm going to be using is at 32 megahertz. Then we do some pre-scaling on that. I think we selected a smaller value of 1684 yesterday from memory, and then that makes that frequency. It changes that and makes it a lot longer in terms of the duty cycle. I meant the frequency. Then we post scale it again to make it even longer, and that generates a long signal. So we took something here at 32 megahertz, and then here we made it into, we made that into 1 second, 1 second, 1 second. So we've stretched the frequency out. Well, if you enable the timer at this point here, as we did yesterday, you will start a counter running inside of Timer0. It will count. We set it to B1, I believe, yesterday. It went B2, B3. It carries on counting in the background for us. And when it gets to FF, it cycles over to 0, and then it's going to reset the counter to 0. And at that point, then it will overflow, and it will make an overflow event inside of that timer flag. Then, once that occurs, if we've got the interrupt enabled, it will raise an interrupt flag. And that's what we're doing. So we're doing all this in 4 commands. We're going to add in the interrupt enable in a moment and make it work. Let's go into SynWrite editor and get this thing done. Okay, all right. Where is the SynWrite editor? Here. There it goes, there. I'm going to take the code from yesterday's session, and I'm going to stick it in session 14, and I'm just going to compile it up and verify it works. Okay, so here's the camera. We've got an LED. Let's see if it flashes. It does. it flashes. So we're going to take the values that we used yesterday, and for those who don't remember, we used a spreadsheet yesterday in Excel that I've now published, and it's got these values in it of 32 megahertz, pre-scaler of 16384, post-scaler of that with a 1 second delay gives me a value of 2C. Oh, that's wrong. Gives me a value of B1. There we go. And that's what we put in our B100. That's what's in our source code. And let's have a look at our source code again. It's here. So how are we going to do this? I'm just going to take this piece of code here and move that outside that loop. Okay, I'm going to do that very easily. So I'm going to set up an interrupt. Once I've set my timer up, I'm going to do an interrupt. On interrupt, it automatically completes it. And what we've got to do is specify the type of interrupt. Well, on interrupt, press F1, and you'll see the on interrupt event, and there's a list of events that you can choose. Well, we know that our event's going to be an overflow event. Okay, so let's have a look at the timer zeros. Timer 1. Oh, there's a timer 0. Timer 0 has overflowed. Okay, microchip and AVR. That's great. That should say PIC nowadays, really. So it's time. That's the syntax I want. So on timer event on an overflow, I'm going to call my interrupt service handler, my SR. All I'm going to do is create a subroutine and end that subroutine. So this won't work because I've got to remove this line here, because when we call the interrupt service routine, it will already know. Great Cow Basic already sets up and knows that this flag has been set, so I can delete that. Now let's recap where we are. We've got a chip. I've set the LED as out. I've set up the parameters of that's the internal oscillator, the pre-scaler, my clock source, and my post-scaler. I've taken the value from my spreadsheet for 1 second, and I've set timer 0 to that, and I've started the timer. You might actually want to do it like this if you really want. Oh no, it doesn't really matter. It will occur. So if I press F6 to confirm it compiles, great, it's successfully compiled. Let's look at my desktop. There it is there. We got a view here where we can, there we go, great. I really want to show you the lab as well, don't I, really? Let's just compile that up and program it into the lab. Click. I've lost the lab. Well, there's the lab down there. Why can't I see it? 1 moment, please. Oh, there we go. It's working now for some reason. So that LED is flashing. That LED is flashing because I've sent it a 1 second delay. Now, let me just try and bring it into a larger picture. It's not playing ball for some reason. Oh, there we go. There it is. There it is. It is flashing at 1 second. Now, let's just go back to our source code. All I've got in here is this. It says flash the LED and clear that flag. Well, in reality, I don't even need to clear that flag, because in Great Cow Basic, for the event that was called, the interrupt event, that is cleared for me. But for good practice, in your own brains, you might want to clear that flag. Okay. So if I now do some other stuff, I'm going to flash the other LED. So we have another LED, if you remember. We're going to do some work. This is your do work piece here. You know, you can add in lots more code in here quite clearly. Do lots of work. Lots of other code. There we go. I just need to add my LED at the top here. LED, we use LED 2. That's on RA2, and we'll set it to an output. So what we're doing here, we've recap, initialize the timer, we've done it on interrupt, we're doing some work, and every 1 second it will flash our LED for us. Let's try that. Well, we can see that we've got the yellow LED flashing. That's the LED here. It's flashing every 100 milliseconds, and we've now got a 1 second delay in an interrupt service routine (ISR). We've done something that's quite complex, extremely easily. Now, for those who want to go a bit deeper, I'm just going to show you the source code, what actually happens in here. So I'm just going to do a little bit deeper, which I don't normally do, but I'm going to show you the assembler that makes this magic happen. And that magic is really very simple. That in the code here, it's got Great Car Basic writes a very robust interrupt handler for you. And that interrupt handler sets up and caches the state of the chip during the interrupt and calls our routine. There it is, call MySR, and then so here it's saving the state. It calls your ISR and then puts the state back. And for those who can read assembler, this is where I said previously you don't need to clear some of these flags. They're done automatically. Well, they are, and this proves it. So today we wanted to show you how to set up Timer0 overflow with an interrupt. I think we've done that. We'll call that a wrap. Enjoy.